What about if we've got quantitative versus quantitative? Well, to do this, we're going to look at the FVC data. So again, this is a spreadsheet this time, so we're going to have to go open data. It's a spreadsheet, so I need to choose this to be Excel. FVC, you get this from my uni. Open. Looks all good. Click OK. So here's our FVC data. So what this is we took 127 12-year-old boys, and for each one we measured their lung capacity as measured by the forced vital capacity. So you basically take a deep breath in, blow it out as hard as you can, and we measure this. So this is in litres. We've measured their height in centimetres and their weight in kilograms. And the idea of this data set was to hopefully develop a model so we could take a 12-year-old boy's height and weight, predict what their lung capacity should be, and then if their lung capacity when we measure it is less than that, then we have an indication they may have early signs of asthma. So the thing is, first we're going to do when we're comparing quantitative, so we're going to compare FVC with height, is we do a scatter plot. So charts, graph builder. Yeah, that's fine. So we come down here, there is Scatterplot. We'll do the simplest one here, which is simple scatter. Drag that up. And we want to predict lung capacity using height. So the thing we want to predict, the response variable, goes on the y-axis. And the thing we're going to use to predict it, in this case height, is going to go on the x-axis. Then we click OK. And there we have it. So, as always, when you're looking at these things, you want to start describing the patterns you see. So the first thing we look at is we say, is this reasonably linear? Could you fit a straight line to it? Or is there some sort of curvature, or what we call non-linear pattern? This generally looks pretty good. Next thing we want to know is as we go from left to right on the x-axis, in this case it's height. So as we go in this direction, what happens with lung capacity? As you see, it goes up. This has a positive slope. So we've got a positive linear relationship. How strong is that? It looks reasonably strong. You know, if a pencil would fit over, you'd say very strong. With this, you could put a cigar over it, so it would say strong. If it was sort of generally, you know, much more spread, you'd say weak. And then if there's no relation, you'd say no relation. But I think this is a strong, positive, linear relationship. But now we know that this generally looks like a linear relationship, we can actually measure that with the correlation coefficient. So to do that, we're going to go Analyze, Correlate, Bivariate. And the two we're interested in is FVC and height. Should be all we need to do. We click OK. And this gives us our things. So the numbers we're interested in this case is the Pearson correlation. So first of all, this one's really a bit of nonsense. It's just saying that if you correlate FVC with itself, you get a perfect relationship, which makes sense as well. This is what we're interested in. This is the Pearson's correlation between FVC and height, which is 0.790, which confirms our strong positive linear relationship. It's also repeated here. This is height with FVC, this is FVC with height, but the same things. Also, this number is how many was used in the calculation, 127, which we knew. So what if we actually want to make that prediction model? That is, we want a model that if I gave you height, you'd be able to predict the forced vital capacity. To do that, we're going to do linear regression. So again, we come up to Analyze. This time we're going to go Regression, and we go for linear. So we want to predict using height to get FVC. So FVC is going to be our response variable, or what SPSS calls dependent. So FVC is going to go dependent. Our independent, or our predictor variables, in this case is going to be height. And that's what you have to do at this stage. Click OK. So I have a lot of output here. The main one you need at this point is the coefficients. So this is going to give you your model. The first line is going to give you your intercept, and the second line is going to give you your slope. So as you're seeing the solution of the notes, this means if I wanted to predict FVC, I would take minus 5.065 plus 0.052 times height. And that, when I do that calculation, would give me my predicted force vital capacity for that height. Often we will ask you to interpret these coefficients in context. So the first one, this is the intercept. This basically says if height was 0, this is the predicted force vital capacity. Well, there's two things to note about that. There will always be an intercept. When you have a straight line, it will always cross the response variable axis, but it doesn't always make sense. So in this case, if you think about it, I'm trying to predict the lung capacity for a 12-year-old boy who is 0 centimeters tall. It's nonsense. And you can see it's nonsense. It's giving me a negative. It's basically saying its lung capacity is negative. This is just part of the fitting process. Sometimes the intercept is important because we're actually interested in that. But in this case, it's just part of the fitting process. The height's more important. This height, the second line, gives me the slope. And the way you interpret the slope is we say in this particular case, if I increased the height by 1 centimeter, because that's the units we're looking at, if I increase the height by 1 centimeter, then on average, the forced vital capacity would increase by 0.052 litres. So the slope is how much your response variable increases for every 1 unit increase in the x-axis, or the predictor. Okay, that's everything. See you next time.